As you can guess by this title page, we're going to be factoring. So let's factor. We're going to be factoring out common monomials. We're going to use factor by grouping for polynomials, for quadratics, for other polynomials, and for in some unique ways as well. So let's start off with factoring out a common monomial. So factoring common factors, we use the distributive property to expand algebraic expressions. We sometimes need to reverse this process, again using the distributive property by factoring an expression as a product of simpler ones. So for instance, x squared minus 4, if we are factoring, we can factor that into x minus 2 times x plus 2. If we are expanding, right, we can multiply those two binomials and we would get the difference of squares, x squared minus 4. So we say that x minus 2 and x plus 2 are factors of x squared minus 4. The easiest type of factoring occurs when the terms have a common factor. So we're going to factor out a common factor, and I believe all of these problems are in your notes. So the first one, 3x squared minus 6x, our greatest common factor would be 3x. Both those terms are divisible by 3x. So if we factor out a 3x, we're just going to divide both terms by 3x. 3x squared divided by 3x is x. 6x divided by 3 is 2. So that's going to be 3x times x minus 2. That's all there is to the first one. How about the second one? All right, let's find our greatest common factor. Well, the coefficients are all even, right? 8, 6, and 2, those are even numbers. So our greatest common factor is going to have a 2 in it. Let's see. We have x to the fourth, x cubed, and x. All the terms have an x in it. The smallest exponent, though, is just x to the first. And then we have a y squared, a y cubed, and a y to the fourth. So y squared is the smallest exponent. So notice I can't take out a factor that has an exponent greater than the smallest exponent in any term. Right? So x is the smallest, x to the first is the smallest exponent on x, and y squared is the smallest exponent on y. So we're going to just factor out a 2xy squared. All right, so and divide everybody by 2xy squared. Well, 8 divided by 2 would be 4. X to the fourth divided by x is x cubed, right? We just subtract exponents. And y squared divided by y squared, well, that's just 1. So no more y squared. All right, 6 divided by 2 would be 3. X cubed divided by x would be x squared. And y cubed divided by y squared is y. And the last term, right, so we have 2 divided by 2 is 1, so we don't need to write that. Oh, but we should write the subtraction sign. X divided by x, again, that's 1. And then y to the fourth divided by y squared, that would be y squared. So here is our expression factored. We factored out the 2xy squared, and then the leftovers are in the parentheses for each term. 4x cubed plus 3x squared y minus y squared. Let's do the last one. I kind of took a lot of space doing that second one. So I'm going to work above. I'll write the greatest common factor here, but I'll work above. So the greatest common factor, let's see, we've got, so now look at our factors are not single terms, they're binomials. So if you notice, both of these, both of the two expressions there have an x minus 3. Our greatest common factor is an x minus 3. So we don't have to just factor out a single monomial, we can also factor out a binomial. All right, so I'm going to just put it up here. So we're factoring out the x minus 3. Make sure you put it in parentheses, right, because it's that whole factor that we would be multiplying if we were to distribute it back. All right, so if we divide 2x plus 4 times x minus 3 by x minus 3, we're just going to be left with a 2x plus 4. If we divide negative 5 times x minus 3 by x minus 3, we'd be left with a negative 5. So you see that the leftover terms, this binomial and that monomial, are what's in the parentheses because we have factored out an x minus 3 from both those terms. Now you notice we have some common factors, and we should add those together. So this is going to be x minus 3 times 2x plus 4 minus 5. That's just going to be minus 1. And there we go. Right? We have factored it. That's all there was to that one. Right? Let's look at another problem. All right, so factoring trinomials. All right, so now we're going to use factor by grouping, right, to factor these two. All right, so we have x squared plus 7x plus 2 and 6x squared plus 7x minus 5. All right, and no matter how simple or how complex a quadratic is, we can always use factor by grouping. Our first step, well, we want to make sure we have it in standard form, right? The squared term and then the x term and the constant, and we do. We want to identify, whether we write it down or just do it in our head, a, b, and c. A is the coefficient on x squared, b is the coefficient on x, and c is the constant term. And then we figure out what a times c is. Okay, well, 1 times 12 would be 12. So we are looking for two numbers whose product is 12, but whose sum is the b term 7. So this is a times c, and this is b. Because remember, if we multiply two binomials, we get 4 terms. Somebody went and added 2 of the terms together. All right, so the two numbers that multiply to give us 12, add to give us 7, of course, are 3 and 4. So now we're going to replace the 7x with a 3x and a 4x. And it doesn't matter the ordering you put these two in, right, as so long as they are your two center terms. And the other two, I kind of color-coded there, the other two remain exactly the same. The first two become a group, and you can just put it right, you can, the one you just wrote, you can put the parentheses in, or if you want to rewrite it, you can. All right, so we've made the first two a group and the second two a group, and then we pull out a greatest common factor. So x squared and 3x are both divisible by x. If we divide x squared by x, we'd have x. If we divide 3x by x, we'd have 3. 4x and 12 are both divisible by 4. 4x divided by 4 would be x, and 12 divided by 4 is 3. And now you can factor, it's just kind of like what we just did on the last slide, right, where it was already factored, and we factored out a binomial, right? We're factoring out a common binomial. This is a factor for both of these expressions, x times x plus 3, x times x plus 3, and 4 times x plus 3. We're just factoring out the x plus 3, and then we have our leftovers. And there we go. That's all there is to that one. Let's try the second one. All right, so a is 6, b is 7, c is negative 5. So a times c is going to be 6 times negative 5, or negative 30. We need two numbers that multiply to give us negative 30, but add to give us the b term of 7. All right, so if we think of the factors of 30, all right, we've got 1 and 30. We've got 2 and 15. Notice these are too far apart from one another. They're not going to add to 7. By the way, if you have a negative product, one of these is negative. Since our b term is positive, it's going to be the smaller term that's going to be negative. But if we try one more time, negative 3 and 10, look at that. They multiply to give us negative 30, but they add to give us 7. All right, so now we are going to keep the 6x squared. And then we'll replace the 7x with a negative 3x, and I'm just going to put minus 3x, and a positive 10x. And then we keep the negative 5. Make sure when you're grouping your terms, the first two are a group, the second two are a group, there's a plus here. So if you had switched the negative 3x and the positive 10x, then make it 6x squared plus 10x plus a negative 3x. So the negative stays with the 3, and there's always a positive plus there between our two groups. So now we pull out a greatest common factor. Greatest common factor for 6x squared and 3x is a 3x. 6x squared divided by 3x is 2x. And 3x divided by 3x is 1. 10x and 5 are both divisible by 5. 10x divided by 5 is 2x. And 5 divided by 5 is a 1. And then we'll factor out that repeating 2x minus 1. Our leftovers 3x plus 5 are the other factors. And that's all there is to this one, right? Easy cheesy, lemon peasy. Now, these ones look very much like our, well, actually one is. One is just a plain quadratic again. So we will just factor the x squared minus 2x minus 3. But the other expression, 5a plus 1 squared minus 2 times 5a plus 1 minus 3, is also in the form of a quadratic expression that we could use factor by grouping on. All right, let's just do the first one. All right, so A is 1, B is negative 2, and C is negative 3. 1 times negative 3 is negative 3. We need two numbers that multiply to give us negative 3, but add to give us the B term of negative 2. And of course, that's going to be a negative 3 and a 1. Right? So this AC is just telling you that that negative 3 there, that's just the product of A and C, and that negative 2 is the B term. All right, so we keep the x squared. We're going to replace the negative 2x with a negative 3x and a positive x, and then we keep the negative 3. And the first two are a group, and the second two are a group. Greatest common factor for x squared and negative 3x would be an x. If we divide x squared minus 3x by x, we would have x minus 3. And x minus 3 have no common factors. We can factor out that repeating x minus 3, and we're left with the leftovers, x plus 1. Now the second one is easier to see that it is a, it could be factored the same as the expression on the left. If we just do a little substitution, let's just let 5a plus 1 equal u. So that would give us u squared minus 2u minus 3. Hey, we just factored that. U squared minus 2u minus 3, right? We had x's instead of u's, right? But it's the same expression, right? I'm not going to get anything different if I have u's other than it being a u minus 3 and a u plus 1. All right, so here we have u squared minus 2u minus 3 factored, but there's a little problem. Right? That's not our starting equation. Our starting equation had 5a plus 1 in it. Well, let's just replace the u with the 5a plus 1. All right? We decided that 5a plus 1 was going to equal u. We can put it back. So we have 5a plus 1 minus 3 and 5a plus 1 plus 1. All I've done is, actually, let me color code it so that you can see. All I've done is replace the u with a 5a plus 1. And there we go. So now all we need to do is simplify it, and we have now factored it. So if you have an expression like b there, where you've got a something squared and then a something and a constant, and your something squared and your something there is a binomial instead of a monomial, single variable, then try replacing it with a single variable and then see if you can factor. Because if you can factor u squared minus 2u minus 3, you can also factor 5a plus 1 squared minus 2 times 5a plus 1 minus 3. So our last step is just combine like terms. 5a plus 1 minus 3 is going to be a 5a minus 2. And 5a plus 1 is going to be a 5a plus 2. And there we go. And if you were to multiply this out and distribute, you would get right back to the, you can get back to the same expression that we started off with. All right, but it's a lot easier just to factor it than to go the other way. All right, and I'm going to pause this video, and then we're going to pick up with special factoring forms. Thanks for watching. Bye for now.